Nanostructured gold in ancient Ayurvedic Calcined drug Swarnabhasma. Part 2. Preparation of Swarnabhasma or calcined gold. Swarnabhasma is manufactured by the industry Sri Dattapashuran in Maharashtra, India. The detailed process of manufacturing is reported here. Pure 24-karat gold foil, mercury, and sulfur were procured from authentic sources in Mumbai. The three substances were processed by specific purification Shodhan techniques. Reported literature of Rasa Shastra. Purified denotes processed by specific methods of Rasa Shastra. Following processes were carried out for purification of the gold, mercury, and sulfur. Pure gold foil was cut into small grained pieces. Gold pieces were heated until red hot and quenched in decoction of Burhanera variegata, Leguminosae, thrice, followed by air drying. For purification, mercury 99.9% pure was titrated with a paste of garlic, cloves, allium sativa, and powdered rock salt for 7 days, and further washed with lemon juice and water. For purification, sulfur was melted with cow ghee, clarified butter, and poured into cow milk 7 times. It was then washed with warm water, dried, and powdered using a grinder. Materials required for manufacture of Swarnabhasma include purified gold 1 kilogram, purified mercury 2 kilograms, purified sulfur 16 kilograms in divided quantity per puta, and juice of C. medica. An iron mortar and pestle were used for pounding purposes. Earthen crucibles and fuller's earth were used for preparing encapsulated case, Sharad Samputa, of material to be calcined. Cow dung cakes were used as fuel during the process. Process of incineration demonstrates the process of manufacturing of Swarnabhasma. Detoxified gold and mercury and juice of C. medica were pounded to form an amalgam in a slightly warm mortar pestle of cast iron. Amalgam was placed in an earthen crucible with equal amounts of sulfur powder and covered from above by another earthen crucible, and a joint was sealed by an aqueous paste of fuller's earth and cotton cloth. The seal was allowed to dry, leaving a compact space available for reaction inside the crucibles. This case was heated with 30 cow dung cakes in a pit called puta, reaching gradually up to a temperature of 900 degrees Celsius. The assembly was allowed to self-cool. Contents were collected by breaking the seal carefully and were titrated to homogeneity. Further, the content was calcined again in the presence of an equal amount of sulfur in a similar way for 14 times. The mixture was converted into a powdered form of Swarnabhasma. Figures showing making of Swarnabhasma by traditional process of Rasa Shastra. A. Pure gold. B. Heating of gold. C. Quenching in the Kancharna decoction. D. Drying of gold. E. Amalgam of gold AU and HG. F. AuHG amalgam and sulfur is placed in earthen saucer. G. Sharav Samputa. H. Bhasma formation after repeated incineration. I. Sample of Swarnabhasma. The FTIR confirmed presence of water. The EDXRF confirmed the absence of mercury in the finished product. Confirmed the presence of gold, SiZrNB, SClK, CaFe, and Ni. The peaks of gold are prime and all other elements are in trace. The FTIR confirmed presence of water molecules over the sample, and no other functional group could be ascertained. Gravimetric test from investigation sample, 95% gold was obtained by gravimetric method. The investigated sample of Swarnabhasma was prepared by incineration. Above, the amalgam prepared in the presence of citrus juice and further addition of sulfur. Mercury is believed to play an important catalytic role during the Bhasma making process. Gold, being a noble metal, resists any oxidation, and hence it's a challenge to convert it to Bhasma or powdered form. Interestingly, absence of mercury in the final product, Swarnabhasma, was evident in the ICP, AES, and the EDXRF. EDXRF is an X-ray fluorescence technique used for elemental analysis. It's a non-destructive analytical technique. An X-ray beam with enough energy to affect the electrons in the inner shells of the atoms in a sample is created by an X-ray tube inside the handheld analyzer. Light elements have very limited sensitivity for detection by this technique. This is a surface-based technique, unlike the destructive techniques like ICP-MS and ICP-AES for elemental analysis. This is because it's a surface-sensitive method. The intention to carry out EDXRF and ICP-AES was detection of elements in Swarnabhasma, especially to check for the presence or absence of mercury, which has been used in the manufacturing process of this sample. FTIR identifies chemical bonds in a molecule by producing an infrared absorption spectrum. The spectra produced a profile of the sample, a distinctive molecular fingerprint that can be used to screen and scan samples from different functional groups. FTIR is an effective analytical measurement for detecting functional groups and characterizing covalent bonding information. The presence of organic functional groups is important. Only water molecules could be identified in the investigated sample. Water molecules may not be a part of Swarnabhasma, but absorbed over its fabrication. FTIR showed water molecules, or OH groups, that are absorbed on the surface after its fabrication, and this technique is used for detecting any attached functional groups. For instance, in case of AUNPs prepared by non-Ayurvedic contemporary methods involving green synthesis. In case of Swarnabhasma, no other functional group could be identified because the calcination process involved high temperatures. During the process of incineration from the pounded gold mercury amalgamate, the mercury might be escaping in vapor form, and sulfur might be escaping in sulfur dioxide form. This is most likely a layer-by-layer conversion of gold into Bhasma particles during the 14 incinerations. Sulfur was added each time in the closed casing comprising a previously calcined and further titrated gold compound. Swarnabhasma prepared in this way is stable and does not revert to its original metallic state. The mercury amalgam may be acting as a growth-directing agent. It is hypothesized that mercury may get vaporized and sticks itself to the pores of the earthen vessel, which needs to be confirmed by analysis of earthen vessels. Further research is needed for checking this. The techniques of mercury determination can be used for such analysis. Powder XID method is the best known sensitive method as a phase characterization tool. XRD confirms Swarnabhasma to be pure gold and not its oxide or sulfide. Faceted growth of gold nanoparticles is evident by the XRD. The nanosize and amalgamation of particles is evident by TEM and FE-SEM. The ability of nanoparticles to form larger agglomerates or any assembly has been extensively noted in literature. The agglomerates are aggregation of gold nanoparticles in large micrometric size. This aggregation is due to sinterization of high temperatures, and the particles are bound by certain forces. The agglomeration tendency of particles of gold basma is significant and may have a role in its action and our use of anaponas. It's evident from a previous research study that when administered intravenously into a mouse model, gold nanoparticle superstructures of reversible agglomerates and irreversible aggregates demonstrate significant difference in organ and cellular distribution compared with the primary particle building blocks. The main advantage of Swarnabhasma is its stability and its claimed safety, as understood by use since ancient times as a medicinal agent. Stability is known by the irreversible nature of particles. Even after a long-term storage, it's known to be irreversible. A Purnabhava test is a unique test that depicts the irreversible nature of the basma in this study. There are specific iatrochemistry-based tests used to check if the basma, in its conversion from raw to consumable, is complete. If the basma is not properly formed, there's a relapse of metal particles in a Purnabhava test. The test makes use of charring of basma with a bolus of a precanderous seed powder, gunja, cow's ghee, honey, madhu, borax, tankana, and jaggery. There is nothing but extracting metal from its compound by traditional biochemical way, which is unexplored mechanism. Drug delivery of Swarnabhasma is done in a specific way in which basma particles are mixed with a media like honey, ghee, etc. The hierarchical nanostructured gold basma particles have high surface area and when mixed with honey or ghee, presumably release their agglomeration and get universal dispersal and separation of the particles, resulting in larger surface area. Further research on these drug delivery systems of Ayurveda needs to be done. Around 60 accompanying media and medicaments as Annapurna or Yoga of Swarnabhasmas is available in ancient Ayurvedic literature. This includes honey, ghee, medicated milk, medicated clarified butter, and many more. Retrospectively, to understand the events in the closed earthen container, during incineration, thermogravimetric analysis, and differential thermal analysis of the amalgam and compound were carried out separately. The gold Hg amalgam was tested for comparison with actual gold HGS combination for comparison with the thermoanalytic technique. Of course, the actual setting of this incineration used traditional Puda was not duplicated here. However, the thermoanalytic technique was used to assess major endothermic and exothermic reactions of elements in the amalgamate to get a rough idea of the phenomena. From the DTA, it's evident that around 750 Celsius, the gold in the amalgamation shows endothermic reaction and possibly at 750 degrees Celsius to 900 degrees Celsius gets converted to light brown colored powder, basma. Due to the compounding with the citrus, probably before the melting point, the metallic gold is converted into basma form. Just to check the difference, the DTA and HG citrus amalgam is compared, which shows a different behavior, showing low inverted peak at 850 degrees Celsius, unlike the AU-HGS compound. Citrus juice from the juice of the C. medica acts as a reducing agent for decomposition of amalgam into gold particles. The maximum temperature of the traditional kiln for making Swarnabhasma is supposed to reach to 800 to 900 degrees Celsius. The melting point of gold is 1,604 degrees Celsius when it's in its metal state. It appears that the whole of the Hg and S transform from the solid state to gaseous state around 300 degrees Celsius. As per the experience of Ayurvedic physicians, if calcination is carried out under a higher temperature, up to 1500 degrees Celsius, there cannot be any formation of particles of Swarnabhasma, and gold reverts in metallic state after calcination. Being a noble metal, gold does not succumb to oxidation and sulfide formation. The peak at 750 degrees Celsius indicates major endothermic peak, where conversion may be taking place into powdered form, basma into gold. This endothermic peak is absent in the major exothermic peak at 300 degrees Celsius indicates boiling of the mercury. Most of the conversion of gold into basma might be taking place around 750 to 900 degrees Celsius. The titration process in iron mortar pestle after incineration facilitates breakdown of particles. The amalgamation is composed of 300 degrees Celsius and further at 400 degrees Celsius, where exothermic peak due to oxidation of sulfur and the evaporation of the mercury. It's presumed that around 300 degrees Celsius, all the mercury might leave the amalgamate, escaping out of the basma. Due to the Rasa Shastriya purification, the Shodan process might be an alteration in melting point and boiling point of mercury. However, this can be confirmed by further systemic research to understand the effects of Shodan. In this study, the nature of particles of Swarnabhasma and their size is evident. The particles are in a 5 to 20 milligram range, which is smaller than that of human cells. In a previous pilot study, bioavailability of gold basma has been assessed in humans. Particle size is a crucial factor that regulates circulation and navigation of nanomaterials in bloodstream, penetration across physiological drug barriers, site and cell-specific localization, and induction of cellular responses. Apart from gold, the Swarnabhasma marked presence of other elements in smaller amounts. Organic and inorganic drugs used during the processing of raw materials and the lemon juice used during the amalgamation contribute to the presence of these elements in the final basma of gold. Apart from the gold, silicon showed its presence in maximum amount. Silicon is the second most abundant element in the Earth's crust, marking its presence in soil and plants. Iron metal pestle used for the preparation of amalgam and further pounding of calcined part after each calcination may also have contributed to traces of iron into the formulation. Swarnabhasma is a Rasa Shristra medicine which is used since ancient times for the medicinal purposes. Swarnabhasma is reported to promote longevity, combat aging, enhance strength and potency, and is used as a tonic, hypotonic, cardiostimulant, nervine tonic, detoxifier, and anti-infective drug. It's also used for treating anemia, dyspepsia, epilepsy, neurasthenia, memory loss, bronchitis, asthma, tuberculosis, and rheumatoid arthritis. This indicates the diverse target action of the drug. The exact mechanism of action of this drug is yet to be explored. Gold basma has been investigated in a preliminary study for cancer management. Various studies conducted globally have focused on the use of gold nanoparticles in the management of cancer. Its bioavailability, cellular entry in vivo, and response of tissues to it needs exploration. The claimed action of gold against toxins by Charik Samhita needs to be explored through research. The challenge of toxicity issues of contemporary IUPNs can encourage scientists for the exploration of new methods for synthesis of the gold nanoparticles. On the contrary, Ayurvedic Basma, when prepared correctly as per guidelines in Rasa Shastra, is safe and time-tested. Some novel approaches using gold basma have been investigated in preclinical and pilot human trials on breast cancer therapy. Due to the rapid development in technologies for the chemical synthesis of gold nanoparticles over recent years, a great variety of particles with different sizes, shapes, structures, and optical properties are now available to contemporary researchers. As safety is the prime concern of nanotechnologists, Ayurvedic formulations must be explored scientifically for in-depth knowledge and more judicious use. Exploration of various traditional methods of preparation of calcined gold can help to enhance our knowledge about gold's immense pharmacological actions and its therapeutics. They investigated the Swarnabhasma. In conclusion, it comprises of pure gold nanoparticles. It concluded that there is no mercury left after proper preparation.